If you're trying to figure out how to actually integrate AI, improve your platform, or make the dev experience better for your team, then InfoQ Dev Summit Boston 2025 might be worth checking out. It's 2 days in June focused on the real-world side of adopting these technologies. You'll hear from senior engineers who've already been through it, what worked, what didn't, and what they do differently. It's built for teams who want to move past being inspired and start taking action now. Join us this June 9th and 10th. Learn more at devsummit.infoq.com.
Hello everybody, I'm Oliviu Pop, an InfoQ editor, and I have in front of me Jade Abbott to discuss about probably the most important things in terms of LLMs and AI. But without any further ado, Jade, can you please introduce yourself?
Yeah, hi everyone. Thank you so much for having me on this podcast. My name is Jade Abbott. I'm the Chief Technology Officer and co-founder of African AI startup Lelapa AI, where we do language technology for African languages.
Thank you. Your title for the presentation was very interesting because I'm attracted like a moth to the flame by these ecological and ethical aspects, but you had all of them together. So given that you're an entrepreneur, a co-founder, what's the utopia that you're aiming for? What's your mission? What you're trying to solve with Lapa AI?
We could take the small look at the problem we care about. There's also the big, broader one. I say small, but it's actually very large. And so for us, it's to enable universal communication. Right now, I think as a society, communication is our biggest tool. And I don't think we've even mastered it even when we're speaking the same language, never mind when we're speaking different languages. And so to really expect the world to move on and collaborate and build towards a better future, we really need to be able to speak in each other's languages and be able to communicate with everyone. And so that's kind of the long-term dream of Lelapa itself, is really building the tools and technologies to enable that. But in order to do that, we have to solve a number of other problems. And those other problems are really helpful not only for this particular issue that I've raised, but they're helpful for the entire world. And so here it's really looking at how we can use AI tooling, make it more efficient, whether it be data efficient, compute efficient, in order to still solve those problems. And the reason this is beneficial for everyone, and this is kind of touching on that as an entrepreneur, as much as we want to be sustainable and ethical entrepreneurs, the other motivation is that it costs less. So you're actually making it more affordable, more accessible, and growing your markets by making AI smaller and less dependable on large amounts of data.
That makes sense. And in the end, given that you had a lot of focus on the African continent, that means 1.5 billion people, if I remember correctly. Also, what it means is that they are burning a couple of stages in a couple of aspects. For instance, I just saw a couple of years back an article that was writing that they used to use drones to just dropship medicine because they didn't have infrastructure. So that's creative thinking. But also, I have to ask, as you said, there are constraints. What are the constraints that you have to work around that are pushing the way how you build the things more than what meets the eye? Because we in the Western society, we are used to having infinite streaming, infinite internet, but something tells me that you have a whole different set of constraints.
Yeah. So on the African continent, there's quite a deficit in certain things that are infrastructure in other parts of the world. Things that when you turn your light on, you don't even think about the fact it turns on and that there's an entire network of electricity that supplies that. And for very large amounts of the African continent, reliable, consistent electricity isn't even something you can have. And so when we're thinking about training AI models that might take days and weeks to use, or serving those to people who might not have devices that can handle, high battery loads and things like that, that's just one of the big issues that you're seeing. On the other hand, kind of similar to you talking about that kind of leapfrogging component of where Africa leapfrogs certain technology advancements, and we can actually move quite fast with it because we don't have legacy dragging us behind. There has been a huge penetration of mobile devices in Africa. So in some countries, it's even up to greater than one. So each person has greater than one mobile device they have. They may not have a laptop. They may not ever have access to a computer, but they do have high mobile penetration. And so you've kind of got these interesting contrasts where we don't necessarily even have good supply of water, a sustainable supply of internet yet. The internet infrastructure is still being built, but there's clearly a appetite and need for these devices. And so with that, you're working in a very different space. You don't have reliable internet connectivity. What does that mean for serving a AI model that's sitting on the cloud? Does it need to be on the edge? Does it need to be on the phone itself? If we don't have large amounts of electricity or water availability, how are we building data centers? How are we getting access to GPUs that aren't on the African continent? What does that mean for the data sovereignty that we have? Europe's got really great protocols with GDPR, and that's all good and well because you've got a lot of local data centers, and a lot of those local data centers have accelerated compute, whereas this is only changing now on the African continent. And I think the last one is this data aspect. 98 or some other large percentage, I think it might even be higher, percent of the internet is English. And not only is it English, it's mostly English, Western, white, male. And so if we're building all these LLMs and we're using this as the basis for our data, we're just not going to have enough data to be able to build it for the languages that we have. And so we have this big data constraint where people historically have been punished for publishing in their own language. And this has happened across a number of countries. They were enforced to take on the colonizers' language, whether it be English, French, Portuguese. And when they spoke out of turn at school, they were punished, put in detention, expelled. If someone published in that, they were actually imprisoned. And so there's really not been an incentive to capture the text component of this and have this digitized. And so when we're building these models, you don't have all this data available. You need to figure out ways to be clever about the data that you actually collect.
So first of all, it's about the basic infrastructure that we take for granted in the, let's say, Western world, where you have to be creative in the way how you're doing the basic stuff when you're discussing about models, meaning that how you train it, how you can have like long strides of accessibility to that model. But from my understanding of what you mentioned on the mobile side is being mobile first, it doesn't necessarily mean mobile internet, but it might be the case that people have phones but don't have internet. So that means probably text to speech and other perspectives. So this starts to become a very heterogeneous ecosystem, something that it's an interesting engineering challenge, I have to admit, but also something that is a headache from the operational point of view. The other point that you mentioned is about the scarcity of the data that you have at hand for building those models, because there are a lot of projects. Well, the one that comes to mind now is the Project Gutenberg that transcribed or put into digital form a lot of the books of the Western society. But on the other hand, we are discussing about a continent that didn't have anything like that. So a lot of things got lost, or they're just verbally kept, and all this kind of things. This is what I remember also from your presentation, that there are a lot of things that are still very, I don't know, let's call it antique, when everything was pushed from one person to the other through voice. Congrats on taking this challenge. It's an impressive one, but how do you crack it? What are the lessons learned so far on tackling that?
Yeah, I mean, I think the first lesson is you have to be cautious of the hype of bigger is always better. So we've seen in a couple of proof points that having a bigger model and having more data doesn't necessarily mean that you're going to end up with significantly better results. And second to that, what are we solving for? A lot of AI is solving for improving AI's sake, seeing how far we can push it rather than grounding it in a particular problem we're going to solve for. And what we find is when we ground it in a particular problem and saying, cool, well, we want to solve for XYZ in education or ABCD, your scope of your needs, of your data, of your size of your model become more clear. You don't have to solve every problem. You don't have to get infinite data because that data isn't available. And so that kind of focuses into the kind of type of data you want to gather. On the data component is really focusing on what data do you need? What data will solve your problem? Who are your users? What are they using it for? And less around extraction of data, we think about data creation. How are we creating data? And like I said, this is quite an expensive task to go do, both in time and in money. But how are we incentivizing the creation of data that fits the requirements that we have in order to build it? And so you're taking this really big general problem and saying, okay, well, we're not going to start with generalized AI. Let's start with something that solves the problem. And I think that kind of grounding has been very big for us in doing that. And so focusing on techniques that make things smaller, make things more efficient, that can get the most out of the little data that we do have and can create, but then also making sure the scope of our problems that we're solving are grounded in real world and tackling them as such, not as one big, gigantic general problem. People like talking about AGI, where the G is the general intelligence. And I sometimes ask, what is general? General for whom? And so this is really asking that question, general for whom? Often that does not include the majority world. And so we start by solving the actual problems. And one day that might build up to something that could be more, I'd say, general, as in more domain inclusive, would span multiple languages, etc.
Okay, so you just take the big problem where generally my feeling is that the general ecosystem tries to solve the problem without knowing what we actually want. So then they just throw upfront something. Okay, we have this thing, but it doesn't actually solve something. And you just apply divide and conquer. And you break it down in smaller pieces. And then you just optimize up to not the optimal, not 100%, but that percentile.
What adds value? Yeah.
Exactly. So that also means that you'll have more or less a model zoo where you just have different models and then you use them on different problems, use a different model depending on what you have. And then that means cascading those, requests or something like that.
Yeah, essentially we build up a lot of smaller models. And even now I look at everyone, I think part of LLM is a branding thing. To say that there's one model behind that is actually a lie, because I already know that there are multiple models. And so we just are very explicit about we've got 10 of these models that we can switch between, that we can use a mixture of experts on, etc.
Yeah, that's quite interesting, because I think last year at InfoQ there was a similar discussion, and where there was the try of making the difference between the product itself and the model, because behind the scenes you have the model, but between the interface and the model there is a long way and a lot of parameters and everything like that, and how the things are working. So that's quite interesting. You mentioned making data. What does that mean? Are you using synthetic data? I'm curious about, you mentioned the scarcity of the data, the fact that you cannot rely on typical things like, I don't know, a vocabulary or something like that, because if it's verbal, it's something that it's very easy to just go left and right, and something that probably can vary from one village to another. How do you tackle that? Did I understand correctly? You're talking about synthetic data, and if you're doing that, how do you manage to generate those things?
Yeah. So once again, that whole focusing on a problem. So we might say we want to focus on doing, I'll take a boring use case, but it's a clear one, call center transcription in Johannesburg. And so with that, we're like, okay, well, what do we understand about the problem? We know that there's an agent, they've got scripts, they have to complete certain things. We know that there are people who need to receive that. Now, that data actually does exist recorded, probably not transcribed in a lot of these organizations, but we can't use it due to privacy reasons anyway. So even if that data were there, we can't use it. And this is why our techniques are kind of broadly applicable beyond just having these resource scarce, is that sometimes things are resource scarce because there's a privacy issue. And so in this case, what this means is that we hire teams of people who were call center agents. We put in a system that mimics a call center. And then we have teams of people who are paid to phone in, and they have some sort of guidelines for a script. Often the people who are running the calls are call center agents. So you're basically creating synthetic data, but not through means of using some AI to do that, because fundamentally, we don't have the distributions to even sample from. And so what we really want to do is create this base corpus of very high quality data where we can make a lot of decisions. Because if we know that we need it to work in Johannesburg, we need it to work on, this is the age range of people calling in. These are, need it to work on all genders equally. It means we can construct our data sets to reflect that. It allows you to take a lot of the constraints and SLAs that you would have on your end model and actually move that further back into the data to say, cool, well, now that we're creating data, let's create it correctly. Fundamentally, what that means is that each time problems are coming up on the model, we also then analyze what the model might have done with a small piece of client data. And instead of using that data, because once again, a lot of this data is highly protected, you might say, okay, what are the features of this data that we need to now ensure are reflected in the data that we're creating? Sometimes it's rerunning the creation process. Sometimes it is adding noise to it, as some simple adaptions, real world noises. And so it's really this focus on curating and building up this data set over time as we get feedback from users as well.
Okay, so that means that what you're doing is you're getting inspired from real world data, and then you take the information that's needed on that as parameters in a let's say broad equation, and based on that you're generating your data. Okay, because initially I was thinking that probably you're doing some kind of anonymization and all this kind of stuff, but actually you're taking the gist of it. You're just extracting the proper information that you need, and based on that you're just creating what you actually need.
Yeah.
Okay, even though it's a boring use case, as you said, but most of the engineers out there are solving boring use cases because the money are coming from above and people from above. Exactly. So what will be the techniques that the people can take? Like, as you said, try to use synthetic data and just focus on extracting information. So probably, I don't know, looking at the data set, see the broad majority, understand those, and then based on that, generate data that you can use, and then add in sequences, real world noise and other stuff like that. What else?
Yeah, I mean, some of it is how do you make things smaller? So the one thing is don't try the biggest model first, because often it's not even the best one, particularly if you have less data. And so try the smaller models. And also some of this works back from similarly to how you might model, like, okay, this is the problem, this is the people we needed to work for. You also would model the environment you needed to run in. You're like, okay, well, we need it to run with XYZ latency or on these type of hardware, et cetera, et cetera. And then you backsolve from that saying, what is the correct model that can actually run on that hardware? Because you're working within your constraints. I think we have a nice tendency as, being at the front of AI to just use the biggest thing instead of saying, let's figure out what works within the constraints. Then with that, there come techniques that can aid us, whether it be model distillation, whether it be quantization, whether it's putting in some of the really interesting reinforcement learning loops that help improve these models over time. And they allow us to keep our models a little bit smaller and consistently improving.
Normally, when you said look for the model, I was just thinking about Hugging Face, and I'll go there. How should I proceed? I mean, I should start looking at the use case that I have in mind, start putting the things in order. What's your ace up the sleeve? How would you do it?
I have many techniques. And so if you have time and capacity, what you do is you go find a set of them, usually on Hugging Face, that somewhat meet your requirements. And usually they'll be lacking in some way or another. They'll be lacking on the performance aspect. So how well is this model performing on your problem? That's usually your first one. But obviously you're going to fine tune, you're going to train it on your own data that you've created. Or they'll be lacking in a size component, so it might be too big. Or they'll be lacking in a latency component. And so typically I usually grab a few of them and you just run all of them. And that works when you have capacity to do that, or you have a small amount of training comparatively. So maybe it's something that runs in a couple of hours. Fine tuning can be run in a couple of hours in many cases. The way that I like to think about it actually now, so that was back in the day when the models were a lot smaller actually. So you could do that. You could download 5 and run them. Now I prefer to think of it as this process of looking at the set of them, picking the most likely one that'll work, running the test, looking at the results, doing an error analysis, which is kind of that qualitative component of understanding what it's doing wrong, and figuring out if this is something that we can fix with more training, if this is something we can fix with some sort of technique, if this is something we can fix with more data, or fundamentally if this model isn't going to work. And then we need to make a strategic choice of which of these levers we can pull given the resources we have. And then we use that to guide our next decision, whether it be creating more data, whether it be trying to do extra stuff on the model, whether it be abandoning the model and moving to the next one. And so we might run a few experiments in parallel, but typically given GPU resources are quite scarce, we're not usually doing too many. You're usually picking them few that are most likely effective. And what we found is that there is no good pattern. I suppose the main one is if your distribution is so far out of what the pre-trained model has, fine-tuning it quite often isn't going to give you the best result. And so something that's trained in English, you can't just fine-tune to your own language. That's very often not the case. What we have found, however, is that finding something that's closer to your language will fine-tune better, for example. So we have done studies where we trained more generalized base models, but they were Africa-centric. So they were trained with Swahili as their base language and had other languages on top of that. And we took a much larger English model and the Swahili model, which was much, much smaller, and we fine-tuned it, both of them, for specific tasks. And we found the Swahili one performed so much better just because it was trained from scratch using Africa-centric information. Yeah, it's a lot of techniques but actually a lot of human intelligence that has to go into deciding and being very strategic about what you're doing. Those are some of the tricks and the flows and the things that we do. I think one of the big ones is really nailing that evaluation component. Like, is this working?
So that means that it's some trial and error, some flair, and some experience that will help you with everything. But what I was thinking while listening to you is, how do you do the verification? Because what I was thinking that until not long ago, and even though long ago might mean even 2 years now, since all hell got loose with everybody trying to fix everything with generative AI and using the biggest hammer. Because until that point, I felt that ML engineers, AI guys or ladies were white coats, in my opinion. There are very bright people that are doing very interesting stuff, but there are a handful of them. Now it seems that we are somehow making a commodity out of the AI space, and other people that don't have the training and expertise to do it have to do it. So then what I was preaching in the, let's say, couple of months, 1 year, is to create some kind of safety net. As you had the continuous integration on more classical ways of building stuff, but in case of machine learning and in case of artificial intelligence, it's not black or white. It has some shades of gray. How do you recommend tackling that issue? How would you bring the, broadly speaking, artificial intelligence into the continuous integration loop, the feedback loop of a building system of a company?
Yeah. My past is very much focused in the early days of ML ops. I might have claimed to have invented the term ML engineering. I'm still trying to prove that claim 15 years ago, whatever it was. But it was very early, and there was something that very interesting happened to me, is that a client who we were building, funny enough, a language model for, but 15 years ago, you can only imagine the state that was in, came to me and said, well, we have this bug on the model. And here, bug, I'm thinking, oh, there's an error that's happening, et cetera, et cetera. And he's like, no, the bug is that it's not working on X and Y use case. And what was interesting is the engineering part of my brain was like, immediately like, yes, a bug. And the data scientist part of my brain was like, I can't test on one sample. I have to get a representative set of these samples. And so for me, it was kind of encapsulating this idea of what is a bug in AI. Because as engineers, you run tests, right? You've got repeatable test suites. You run them. You run them every time you push something. You run them every time you deploy something. You get a view of it. And so we needed that for these ML-like bugs. And so what became interesting is then what we do is we take this report from the user or the client and map it out into a small test set and encapsulate that as the bug. And the bug wouldn't be solved or not solved like you would have with a engineering bug. You'd have a percentage solve. But ideally, you build up this database over time. So you've got this large database of bugs, or you can call them interest points, or you can call them mini test sets, whatever you want to do, which are essentially designed to measure each of these individual problems. And you track them over time. And so each model, and I'd say every model, probably not, but each candidate model, each model you want to deploy, you make sure you run that test suite against. And everyone goes, but we've got the test set. I'm like, but the test set doesn't give business a lot of information. It doesn't actually give anyone a lot of assurance, particularly if you're approaching it from like a risk point of view. You're talking about a safety net, very similar kind of concepts here. We actually need to see it in that light. And so at the time, went and built a lot of this infrastructure, and now have the regret that I didn't turn it into a startup. And still no one has properly solved this issue. So we'll probably release something open source to do it, at least as a framework sometime soon. Because that's the thing, is that how do you map what is an ML, a machine learning bug? And then everything else fits in from that, actually. And you can say whether it's resolved, whether it's reopened, et cetera, et cetera. And business can be involved.
That's a very nice way of looking at it. Thank you for that. So I don't know why, but I just went back to university days when we were discussing about NP complete problems, that they don't have the ideal solution, not in a feasible time frame, but it has a degree of solving it. And that's my analogy with what you mentioned, that we don't really need to get to the bottom of the problem, but we need to fix it in the most important aspects that are important for a given customer, and that's something that we should aim for.
And you should monitor it.
Exactly, and then monitor it. You said that you're on the technical side, but you're also the co-founder, so you have to think about also the mundane things of a company. Most often than not, you need to look at the impact and how to measure it. Because obviously, when running a company, it's important to see if you're better than yesterday and so on and so forth, even if you go back and forth. How do you measure your impact? I mean, you have a very broad problem, a very distributed problem. How do you measure your impact into the way how your models work in order to see evolutions in your implementation of each day?
Impact is always such a fun one, because I think if you speak to every development fund, they want to know what impact means. It's interesting because we measure it in kind of a multidimensional way, because you can measure it, in terms of the people that have been impacted by your service. So you have clients, your clients have users. How many unique conversations, for example, have you added value to? But then you might also add on, for our open source models, what was the number of people who downloaded them? We don't have uses of them, but we do know who downloaded them. And similarly, for our papers, we have some stats on how they read. And so you can start to see this multidimensional view of like, cool, one thing is very much like, what is the conversation we add value to? And the other side is like, cool, how do you measure like general world impact? How have we changed the narrative, so to say? And that's through our messaging, our publishing, our open source models, etc.
You see, impact was the proper word. Thank you, Jade, because you just put a definition of impact. You're looking at the multidimensional aspect of your work, and that's writing and open sourcing your papers, so your knowledge. You're looking at the open source, people are using it, but also the, let's call it, commercial side of the usage of your. So I'm happy with impact. I'll remain with that. Thank you. There is another curiosity back in the initial discussion where we started. So you mentioned that at points the models that you're using are very small, and then they might work on the mobile itself. But you also mentioned that those mobiles might not be connected to the internet. So that beats the question. And even if they would be, I would expect some data scarcity. So even if you have it, you don't want to go back and forth. And for me, it means that even if I have a model that, I don't know, got improved somehow magically on the device itself, but it's not connected to the whole ecosystem as we are used to having the internet, how do you take advantage of that? How do you make sure that those models that are refined, you gather the information and you get it to the source so you can use it in other places as well?
Yeah, and so I don't think we've reached the point where we're actually doing it, but the framework is there. And so the framework is federated learning. Is that cool? While this phone is not linked to the internet most of the time or some of the time, when it is linked to the internet, are we able to propagate those updates in a privacy respective way to the base model? And so there's been a lot of movement on federated learning. There hasn't been enough in the NLP space or the language space or LLM space or whatever we want to call it these days. I can't keep up. But those approaches of doing it that way are particularly helpful. Often we could say we'll capture the data. And so that's your simplest way. It's like, cool, well, if you upload your data, you can incentivize people, monetary outcomes and things like that. Or we can just build it as a federated model. But this still is quite aspirational for us at this stage. Right now, we're just getting the things to work and getting them to work in the right platforms in the right ways. But yeah, the theory of how we would do it, it's actually something I've got a long list of things as a CTO that I wish I could be doing, but instead I don't know, CTO crying over GPUs is what I like to say. And one of those is just sitting there and setting up some prototypes around the federated learning components in the tasks that we care about.
Great. Thank you, Jade. At the point when you just mentioned that you're discussing about having like a universal conversation, you brought me to my childhood days when I was looking at Star Trek, and I was imagining that, let's call it, utopian universe. And also what's important from what you mentioned and looking at what's happening currently all around the world is the fact that we are all living under the same sun. And it's nice to see innovation coming from places that we wouldn't have expected it. I think it serves as a good lesson for all of us to just try to strive for the best. Thank you for your time.
Cool. Thank you so much.